Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's SecurityBoulevard.com webinar, brought to you by Techstrong and Sneak. My name is Cody J. Brown. I'm the host of Techstrong Learning. We have an exciting presentation ahead, but first I have just a couple of housekeeping notes to cover. First, today's session is being recorded, so if you missed any of our discussion or you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live session. If you have any questions, we want you to send those in using the Q&A tab, which can be found on the right side of the screen. It's also where you're going to find the chat tab, and this is where we want you to engage with your fellow audience members and let us know your thoughts throughout today's program. I will also... Awesome. Yeah. And so at the end of the program, we will also be giving away 4 $25 Amazon gift cards. So be sure to stick around until the very end. So our topic today is security from code to cloud and back to code. And joining me is Jim Armstrong, Senior Director of Product Marketing at Sneak. Jim, welcome. Thank you so much for being here.
Yeah, thanks, Cody. I appreciate it. Appreciate the intro and welcome everybody. Thanks again for joining us today. And today, what I want to do is I'll start with a few slides, and I have a couple of demos that I'll show at the end as well to kind of show some practical examples of this. But really want to kind of talk about how we sort of connect the cloud security and application security together to solve problems that we see, that I'm sure all of you have experienced as well in your jobs. Really, I think part of the underlying reason for this is the changing nature of applications and what cloud has done to that. Even just a few years ago, the application security was focused very much on the code that our developers wrote and maybe some open source packages that they used. Still a very important part of application security. But, a few years ago, the infrastructure that those ran on, the platforms and things like that, were set up by specialists. They were set up by people who racked and stacked servers and plugged in network cables and made sure that everything was wired up correctly. They were locked in rooms in our basements of our offices, and we could see them and audit them that way. And now with the cloud, of course, all that has changed. It's much easier to spin up servers, spin down servers, spin up all kinds of services that may or may not have servers at all. Right, and connect things on the network on the fly. And a lot of that today is done via code because it's faster, it's easier to write repeatable processes via code that will do that. And so all of these things now fall into that same sort of realm, that same sort of process that we have for application security. We have IAC, we have containers, we have all of these sort of cloud native technologies, but all of these things can be defined in code very much the same way that our applications work. And so security can work for those things very much the same way that our application security works. But we don't want to limit it to having our cloud security in one silo and our application security in another silo, right? Part of the idea of DevOps and DevSecOps on top of that is that these things should be linked to each other, and that this is a continuous process that everybody is sort of sharing in and working together to create these and secure our environments and our applications. And that's really what we want to see is these two realms coming together as well from a security perspective. Application security and cloud security need to go hand in hand together. If we have a perfectly secured cloud and we run an app on top of it that's full of vulnerabilities, then it doesn't make a difference. We're going to allow people to get in and do bad things. And vice versa is also true. We perfectly secure our application, remove every single vulnerability in the app and the code, and we leave the front door open in the cloud. People will find their way in. So people are just looking for the weakness and finding ways to exploit that. And then from there, looking for other things that they can do in the environment. So these things have to happen together. And really, the cloud is there to support the apps, and the apps need the cloud to run. So the two things go hand in hand, even from a technical perspective and from a process perspective as well. So the security of those things should go hand in hand as well. The other underlying problem here, I'm sure a large number of the folks listening here today are security professionals, right? And you feel this pain, probably acutely every day. There are far more developers than there are security experts. There are tons of open security roles, and there have been for years and years. So it's hard to hire enough security expertise. even if you could get the roles open, because there just aren't enough people to do that. But development teams keep growing and growing because everybody's writing apps these days. There's more and more code that we're sort of in control of than we ever used to be before. And so this ratio of the number of developers to security experts continues to sort of widen. And so this idea here is we can't expect security people to do all this by themselves, right? Whether that's cloud security or it's application security or the combination of the two, there's no way the security person can do all that by themselves and reasonably keep up with the pace of application development, the pace of cloud deployments, the pace of all of these things. Keep the company sort of innovating and keep the company in front of the competition. And so things have to change. Something different has to happen. We have to be able to get those 100 involved in and actively taking part in security if we're going to reasonably handle this and stay as fast as we want to go. Now, the process for this, for many people for several years, on the application side has been, look, we're going to start shifting left. We're going to start pushing more security towards our developers. And Snyk was very early in this. But everything from the time a developer starts coding, writing their IDE, we want to start testing their code. We want to test their open source dependencies. And we're not going to stop there, of course. We want to continue testing throughout the lifecycle of that application and that code. So as it gets checked into our Git repos, let's scan it again. Let's look for security problems there. As it goes through our pipelines, let's scan it again. Let's check for things there. Maybe somewhere along the way, we put up gates, right? We don't allow things to pass through this pipeline if it meets or doesn't pass some of these tests. But this is a fairly well-worn pattern, or at least a desired pattern for application security. I think a lot of people are trying to get there. So this is kind of where Snyk started, but our cloud these days can follow very much the same pattern. Well, the cloud is the thing that's over on the right. It's the running infrastructure. Most of that starts from some bit of code far on the left. So if you have containers, for instance, you have a Docker file usually, or if it's not a Docker file, some sort of configuration file that will specify how a container should be built and how the code works inside that container. Most of the time it's a Docker file though. But there's some bit of code. Infrastructure is code, clearly the same sort of thing, whether it's Terraform or CloudFormation, or even Kubernetes, right? That specifies how an application is going to work, what the cloud resources are that are required for that, and all those configuration bits. So all of those things start in code. They can be checked much the same way that our applications can be checked, and in many of the same locations. So we want to start from the IDE. Let's check things early. Let's alert the developer that something is wrong so they have a chance to fix it before it gets further in the pipeline. We can check it again in the Git repos, right? All these things are code. They should be going through Git repos, and the same sort of process that we have for code works well there. And again, onto the pipelines, onto the registry, and on into the cloud. So you hear in the industry these days a lot of people talking about code to cloud coverage, and it's really important, right? Again, we want to scan what's there in code, but we also want to see what's in the cloud, and we want to be able to scan that. And in fact, I think a lot of what we've seen from companies, from people implementing this, is that it actually goes kind of the opposite way. They start with auditing what's in the cloud, and now they realize that a lot of that comes from IAC, and they're trying to come back and look at the IAC and match those two things up. And this is really where Snyk has put a lot of focus, is on matching those two things up. If everything is starting in code, then we should scan that and protect it early, and then we should connect that to what's running in the cloud. Right? We want to know what's running in the cloud, though. We don't want to just trust that our IAC is correct, because there's all kinds of reasons why our IAC might not be correct, right? But we want to have a single policy engine, right? If we're checking our IAC and we have one set of policies there, we are checking our cloud environment, and we have a different set of policies there, then it's hard to match things up. It's hard to realize, it's hard to sort of rationalize what needs to be fixed and where the right place to fix it might be. So we want our tools to be linked there, to have that same policy engine, the same view of the world, and the same idea of what's correct, which of course is supplied by you. But we also realize that these things can change, independently, right? So we could have everything, defined in IAC, and that defines our desired state for the cloud. But the cloud as it's running might change. We might some of it might be good sorts of change, right? We scale up to handle additional traffic. And so we have auto scaling groups and new nodes get added, and we expand to handle that temporary traffic burst. That's okay. That's the sort of drift that we want to see, the sort of change that we want to see. But sometimes it's bad. Maybe somebody logs into your Google Cloud console and they start spinning up new VMs, or they change existing VMs, and they don't do it in IAC. So you lose a bit of that visibility. And you want to be able to detect those sorts of things. You want to be able to detect the changes that somebody's made to the resources. And you also want to detect resources that haven't been captured in in that code yet. Things that maybe you've manually moved some applications out. And so you sort of transferred a VM or migrated a VM from your private cloud out to the cloud, right? Those things might not be captured in IAC, but you might want to have them eventually captured in IAC. So you want to detect that, but you also want to detect new things that people are spinning up. Sometimes it could be malicious as well. Somebody gets access to the keys to be able to create new resources in your cloud, and they do so that they can run their Bitcoin miners, for instance. So all of these kinds of things we want to be able to detect. And we want to be able to detect and rationalize, like, is that supposed to be there? Does my infrastructure as code say that that's supposed to be there? And is it running in the cloud the way that it's supposed to be? And then I want to make the fixes in the right place. Most of the time, if you're doing all of these things, the right place to make the fix is the IAC. You want the IAC to be the source of truth. And that way you can always continually apply it. You can audit it. You can check all these things early. And so we want to make those things all come together. But there's more to it than just that. That's specifically talking about the infrastructure. When we start talking about containers and we start talking about the applications running on top of the cloud, we start to look at things like vulnerabilities and weaknesses in our application that people can take advantage of. And the cloud provides really important context to the developer working, far over here on the left, about what they should be paying attention to, right? If you've ever run a container and you've ever run a container scan before, and I would assume most of you have, you're probably aware of the type of noisy report that you get from a container scan. It may list hundreds of vulnerabilities. I've seen a few that go to thousands, but it's usually on the order of hundreds of vulnerabilities. And that's hard. That's hard to sort of sort through and figure out which one of those vulnerabilities do I fix? What's the most important? Well, the cloud, the running state of things, can provide important context back to say, here's what's important in a container. But it can also provide important context back in terms of the application itself, right? We can identify these vulnerabilities in our applications when they're running in the cloud. But we want to go beyond just identifying the vulnerability. We want to give the developer the right context to go back into their code that they know and to make that fix. And we don't want them to have to do all that legwork themselves, right? We don't want them to have to manually connect the dots, or even worse, for you as security experts to have to manually connect the dots from some security alert that happens in the cloud to some random line of code that needs to change to make that security alert go away. We want to make that very clear and very simple to get to, and even automate those fixes where we can. So this cloud provides important context to go back into our code, whether it's our app code or it's the cloud side of the code, and make those fixes. And that's the idea of going from code, where we start creating things, out to the cloud where things are running, and then going back into code to continually fix things. And again, we're completing that loop, that DevOps loop that you have probably seen so many times, right? But it is a continuous cycle. We continue to make our apps better. We continue to find problems and fix them. That's the way code works. It's the way security can work in this environment as well. So with that in mind, let's take a look at a couple of demos, and we'll see some examples of how this might be instrumented. I'm going to start with a cloud and IAC demo, right? We're going to take a little bit of look at infrastructure drift and how we might identify that and those kinds of things. So in this demo, we're focusing on Terraform. I've got some stuff deployed to Google Cloud. We'll take a look at how we can go about first, looking at the code in this and fixing that code, and then how we can identify what's actually running it in the cloud and where it may have changed from that code. Again, that cloud provides that important context for what's different, what's changed, what needs to be fixed, what needs to be captured in IAC, so that we can start implementing this process and this cycle in a better way as well. So let me flip over here to my screen. So this is the Sneak user interface. If you've never seen this before, and I've got many in several things that I've scanned in here. We'll start with this project, which has some Terraform. This is the Terraform that has deployed a GKE cluster for me, and that GKE cluster is out there and running live. So you can see all kinds of Terraform modules here that define all the resources that are out there and running. I picked one here that is one of my EC2 instances that's running in the cloud. And you can see the types of results. So again, I'm showing you in the Sneak user interface. This could be done in an IDE instead. In fact, more users, particularly like cloud engineers and even developers, would probably see these results in an IDE or in their Git repo. But I'm showing you here because it looks a little prettier. So again, we've identified issues here. We've captured a bit of the code so we can actually see the places in the IAC file where we have an issue. We give that engineer or that developer the details they need to go through and actually find this problem in their code and implement the right fix. So I could go through this whole process of actually implementing these fixes in the code. And so I can see, the capture of the code here. Now, all this code sits in the Git repo. So from here, I've connected Sneak to my Git repo where it picks up this code. So I can see the full view of the file. But again, I could do this in an IDE. I could do the same sort of test in a pipeline before I start to apply this Terraform. And I could have, do the scan of a Terraform plan before I apply it as well. So I have lots of different ways I can implement this, even up to and including if you're using Terraform Cloud and you wanted to scan it via Terraform Cloud and via their run tasks and the ability to integrate with things like Sneak, you could run those tests there. So again, this is the way to sort of start from the code and start implementing the protection that you want to have in your cloud. Now, this is... I've actually got two different things running here. So I've actually got another one that's running in Amazon. I've got an EKS cluster there, and I've gone through and I've configured some things to add, a new CIDR block to it. There's a whole kinds of stuff that's running out there in this cloud. But let me show you what sort of the drift looks like here. So I've run these scans already, and I've done a couple of different scans. Now, this is with the CLI, obviously. And let me make this screen a little bit bigger and make the text a little bit bigger so it's a little easier to see. So what I've essentially run here from the CLI, now this is obviously something that I've manually run. You can imagine the same sort of thing happening in your pipelines or anywhere else that you wanted to kind of automate these tests. But I've run this Sneak IAC describe -- drift. And so what I'm looking for here are resources that are configured in IAC and that are in the cloud, but they've changed, right? So these are things that have changed from my original sort of deployment specs in this case, in Terraform. So you can see here, I've got several things that have changed. I have an elastic IP that has been added. I have some changes to route tables. You can see here where I've added the IPv6 CIDR block, right? So this is telling me the things that have drifted. I originally configured to settle this up with Terraform. And from the time I set it up till now, some resources have changed. Here I've got 5 resources that have changed a little bit. And I could rationalize about whether these changes are good and known and acceptable changes or not. For instance, the CIDR block is something that I just manually clicked through the AWS console and set up myself. And so probably this is something I would prefer to have defined in my IAC files instead of clicking through the console and setting it up. But it does tell me that configuration has changed. Now, there's another type of scan we can run, right? That's IAC drift. And the IAC drift is essentially really looking at my Terraform state, and it's looking at the actual cloud deployment, and it's matching those two things up to each other. There's another type of scan that we want to do. And this is a same sort of scan, right? Sneak IAC describe. And by the way, I should have said this before. The Sneak CLI you can get this for free. You can start running these commands and test all this out yourself. Let me go back up there. So this time I ran with a only unmanaged flag here, right? So different from before. I'm not looking at drift. Here I'm looking at resources that exist in AWS, but they don't exist in my Terraform. at all, right? So these are things that are unmanaged resources, meaning they're not covered by my IAC configurations at all. So you can see here, I've got several storage volumes, I've got several instances running in the cloud. All of these things are not covered by my IAC. Lots of IAM configurations that are not covered by my IAC. These might be particularly scary because, again, somebody gets the keys to one of these things and they could do a whole lot of bad in my environment. But again, we capture all of these different things. So these are the sorts of things that we might want to go and say, okay, we need to capture these in IAC. We need to have that early visibility, that early auditability, so that we know exactly what's running at all times. And our IAC has that level of detail. And we can, if something terrible happens in AWS and we need to reset everything up, we have the ability to do that quickly and easily as well. So that's all useful cases for this unmanaged resources. Again, you could think of, on the malicious side, you could think of people who do get access and find ways to spin up their own containers or spin up their own instances and start running whatever software they want to run on your credit cards, right? And so all of those kinds of things would come up with an IAC result. Okay. So that is an example of, of connecting our code and our cloud together. And again, we have to go from that cloud back into the code, right? We have stuff running in the cloud. We need to get that defined in IAC so we can provide those fixes early. Now, that's purely focused on the infrastructure. Again, the other sort of big concern here is what happens when there's vulnerabilities, or if there's something wrong with my code or my application, or even a container, right? But there are vulnerabilities that I want to go and I want to get those fixed as quickly as possible. Log4Shell being a good example because it's so easy to sort of exploit, but also because it shows off kind of how all this can work together. So if you think about Log4Shell, and I'm sure many of you had to deal with this and probably spent a weekend that you didn't want to spend working trying to resolve this. But let's think about what a developer needs to fix something like Log4Shell, right? When we have a cloud security tool and only a cloud security tool, a lot of times that cloud security tool will do a decent job of looking at what's running in our environments. And even with something like Log4Shell, probably being able to identify that we have this vulnerability, right? They can look at the packages in Java applications. It's fairly easy to figure out what's running, the versions of things that are running, and then to identify, okay, we've got a vulnerable version of the Log4j package, and so therefore we need to get that fixed. And it'll give us relevant information. Where is it? What zone is it in? What cloud is it in? What's the name of the cluster or the container? Those kinds of details, right? All of those are relevant and important. But what does a developer need? The developer needs to know, what line of code do I go change to make this thing go away, right? I can use that other information from the cloud tool to help me identify the thing that needs to change. And hopefully it's easy enough to get from that thing back to the code repo. That's not always the case, but hopefully that's something that can be done. But they need to know that. They also need to know, what do I change it to? How do I make this change? How do I make this thing go away? And Log4Shell is particularly interesting. And a lot of these vulnerabilities are interesting in this way. They're not direct dependencies, right? A developer in 60% of the cases, at least 60% of the projects that Snyk scanned, the Log4j package was not something that the developer added directly to their projects, right? They added a dependency, which had a dependency of a dependency and on, that somewhere introduced Log4j. So that means I can't go, do a control F and look for Log4j and change the version. I have to know, what's the thing that I actually added that has a dependency on Log4j, and what do I change that thing that I added to so that it then pulls in the right version of Log4j to make this vulnerability go away. And so it's not as simple as just saying, you have it, go fix it. A lot of times you have to dig a little deeper to get to it. And so what you want to provide a developer, what will help a developer and hopefully close these types of issues much faster, is that exact visibility into their code, right? Here's the code you have. Here's what you need to change it to make this vulnerability go away. Even better, on top of that, you could automate that. You could open a fix PR for them, right? Obviously, you want to do this via Git branches and those kinds of things, but you could open this fix for them, run it through its tests, make sure that it works, that you're not breaking anything by introducing this fix. But with something like Log4j, obviously, you have to get this thing taken care of. And so you can make that even simpler for a developer by automating it that way. So again, the idea here is we want to connect all of these things together. So let's take a look at this Log4j example in a second sort of demo. So again, the idea here is that we want to start as secure as possible, right? So we have an application that we're going to deploy to a Kubernetes cluster. It's a containerized application. So we've already taken our code, we've put it into a container, and we've scanned that container for vulnerabilities, right? This will help us identify container vulnerabilities. We can also look at the code going into the container. We can identify vulnerabilities there. But again, the idea here is we want to set our application out as best we can and make it as secure as possible before we deploy it. So you can see here, we've scanned this container that's running our vulnerable application. We don't know about Log4j yet. Imagine this is a couple of days before Log4j was announced, right? So we've scanned it, and we're starting our developer out by saying, look, you're running this in a container called, this a Java container, as you can tell from the name here. Now, in my company, my fake company, I maintain containers for my development teams to use. So I have a series of containers that are Java containers for anybody running Java apps inside my company that I maintain. I call them Purple Java. And you can see I've identified the Java version that's inside of these containers. So in this case, my application team has scanned their containers, and I'm saying, look, you're using an old version of our internal Purple Java container as your base image, and that container has all kinds of vulnerabilities. So you need to move to a new version that will give you better results. By doing that, you'll instantly go from 724 vulnerabilities to 178 vulnerabilities. Now, 178, still a lot of vulnerabilities, but this is a very simple change for an application team to make, right? If you're familiar with the Docker file, it's essentially changing, really it's just changing two numbers in the Docker file, right? Changing this 21 to a 69. And then I rebuild the container image, and I instantly drop somewhere on the order of 550 vulnerabilities from my final image. So it makes a big step forward. Now, we can identify other things. Maybe you're not using a process like this. You're not maintaining those sort of golden images for your developers. Instead, they're going out directly to Docker. We can do the same sort of thing, right, based on Docker images. So here's another container scan. This time we started from a Docker file. But again, same sort of idea here. In this case, we've identified that the Docker file says, build from Tomcat 8521. And again, we're saying, look, if you build from Tomcat 8569, you get that same sort of reduction in vulnerabilities. So again, here, only change is that I'm not maintaining that sort of golden image internally for the developer. They're going straight to Docker. Either way, the point is, let's get our developer on the best image we can early on and the easiest one for them to sort of use. Now, okay, so we've done that. We've started, we've done the best we can with our app security. We've done the best we can with our container security. We've deployed our application. You can see our mission critical to-do list application running in our cluster here. Now, this, as we said, is vulnerable and is running the vulnerable version of Log4Shell. And so I've got the command in here that will essentially, execute an attack on this application. I'm going to run it, and I'm going to log back in first because I've timed out. Let's see if I still have that. Nope. All right, so I'll run that little script, and there you can see that this application has been defaced, right? So this is exactly what that little hack does, is it will deface this application. So essentially what's happening here is we're using the Log4Shell vulnerability. We've got a sort of a command and control container that's running elsewhere. When I run that command, it makes that connection out to the command and control server, which makes a connection back to my actual application container. and writes code. It changes the application. And so now I have this nice little banner at the top of my page that shows me something bad has happened. The rest of the app still functions just fine. Now, Snyk has partnered with systig, right? We want to be able to protect and look at things that are running in the cloud before we get to actually fixing something like Log4j. We want to implement some enough controls in our runtime security that we could stop this bad attack pattern. We still have to get to the fix, right? We still have to get to the code. And so we want to be able to do both of these things. And so I have systig running in this environment. Again, it's timed out. Let me reload the screen. There we go. Good. And so what systig does is it's monitoring everything that's happening in real time, right? So we can see everything that's happening inside the container here, and it can alert me to things. In this case, you can, as you obviously saw before, I'm not stopping this. I'm not blocking this attack, but I certainly could use systig to block this type of attack. But you can see exactly what's happening here, right? So it sees this process where we've made a connection back to the container. We've opened a shell prompt, and we're just echoing this command straight into the code that produces those web pages that show up in the container. So systig has the ability to see all those things. And again, we could use it to block this traffic, but that would be a far less interesting demo. So I didn't block it in this particular case. But that's exactly what's happening there. So we could use this as a prevention measure, right? Let's mitigate the danger from Log4Shell while we go back to the code and actually fix it. So there's a bit more that happens there, right? We've got the container protection that happens early at development, where we're looking at the container image and pushing our developers sort of to go a better route, build a better container. Now we're running it. We've got systig checking that in the cloud. But again, we don't want to stop there, right? It's not just about the breadth, but it's about completing that loop. And so from systig, we have that information about what's running in the container, and we can use that to actually to improve some of the resolution in our container vulnerability results, right? We said in the case before, we still had like 178 vulnerabilities that were going to be left in the container. In this case, it's a bit less. This is a slightly different container build here, but nonetheless, we still see there's over 130-ish vulnerabilities that are in this container. But what systig does provide is this flag that says this package is actually running inside your container. Again, the idea here with containers is you might scan it, you might get those hundreds and hundreds of vulnerabilities, but that's because a lot of the containers, especially the containers that are easiest for a developer to use, are loaded with so many packages that your application may never need. But they're there because there are a lot of different ways to run an application, a lot of different ways to run a Java application, a lot of different ways to run a Python application, a lot of different ways to run Node applications. And so some of those containers, especially the simplest ones to use, are loaded with all the packages required there, which means your vulnerability count goes up, right? If you get to a slimmer image, you can reduce that. But still, you want to know which of those things are actually important. Well, maybe the most important things are the ones that run inside the container. Anything that's not running, you probably can deprioritize. And so systig provides that information. Again, we're back in Snyk now. So systig is essentially sending information back into Snyk that says these packages are executed in the container when it's running. And I can actually filter my results based on that, right? So I can filter down to just vulnerabilities that exist in executed packages. So that helps to cut down the noise. I can also look at, just the application vulnerabilities or just the container vulnerabilities that exist in executed packages. Again, the whole point here is to help a developer go from that initial scan where we had at least 700 vulnerabilities down to some reasonable amount of vulnerabilities that they can think about and start to fix. I could focus on just critical, right? Just critical app vulns, on and on and on, right? All kinds of different ways to slice and dice these issues to get to something that's reasonable to think about fixing, right? So great, I've identified that this vulnerability exists here. One other thing before I pop to sort of the last part is if I wanted to, right, as a developer, if I'm curious, I can learn more about this type of vulnerability. So you, unlike me, may not let your developers run vulnerable versions of Log4Shell in your environments, even in your sandbox environments, because it can be a little dangerous and, maybe people forget about it. Maybe it finds its way into production. What Sneak provides on top of the vulnerability information is this ability for a developer to learn more about it, or a security person if you're curious as well. Anybody really. It's completely free, completely open to the world. We call it Sneak Learn. And so here we've got an app, an example app. There's a sandbox environment here. In this case, it's Log4Shell, the vulnerability that we're learning about. So we can start up an application that has the vulnerable version of Log4Shell in this safe sandbox environment and learn why it's such a problem and what it does and how it works, and go through fixing it. We have all kinds of lessons available here, even beyond vulnerabilities. So things like, you can see all different kinds of languages here. For cross-site scripting attacks, what does that mean? How do cross-site scripting attacks work? SQL injection attacks, what do those mean? How do those work, right? So all those sorts of things to help a developer as they're coding proactively think, what's the best way to create this code so that I don't have that problem to begin with, instead of waiting for something to point it out. So anyway, that's built in. The last part of this, right? So we said with something like Log4Shell, or a lot of vulnerabilities that exist, really, they're not direct dependencies all the time. It's even easier. It's one thing to say, okay, I've got Log4Shell and I could look at the vulnerability details and it tells me I need to change my Log4j version, right? That exists as part of the vulnerability information. So that's not necessarily all that tricky to get. But I do need to know exactly what line of code I'm going to change to make that issue go away. And so the nice thing here about Sneak, again, we're plugged into the code. We're plugged into the Git repo. So I can make that change directly instead of expecting a developer to go from that vulnerability alert in the cloud and then have to sort of backtrack themselves into the code. So we can click this button. I'm going to fix this one vulnerability. Obviously we could fix a whole bunch of vulnerabilities at once. But again, it's going to go straight into Git. This is going to open a pull request, right, in a branch, in a fixed branch, to make the change for us. But again, everything is detailed and documented here. Whatever your process is from here, you have it fully automated, right? Let's test it. Let's make sure the application doesn't get broken by this change. Let's make sure that no new vulnerabilities pop up because of this change. Let's make sure everything is good and set before we do any of this. But you could, if you wanted to, just see exactly what's being changed here. So if you wanted to manually make this fix, you could do that too. All the details are here in there. So again, it's about making it as easy for a developer to just directly take care of these security issues so that you don't have this big process. So you don't have to just open tickets and hope that they get to it and nag them about why they haven't gotten to it yet. And how long is it going to take them to get to it? When can they get this done, right? Make it simple, put it right where they are, and give them the fix, and they can handle it on their own. And again, we want these things to work together. We want our cloud security and our application security all to work together. We want them to talk to each other. We want them to exchange information. The cloud is there to make our apps run. Our apps can't run without the cloud, and our security is not really good if either one of those is weak, right? All people need is a weak link in the chain to implement their attack. So that's all in terms of the presentation today. I wanted to see, Cody, I don't know if there were any questions. I see the little red bubble up there. So
yeah, Jim. So we did get a couple of questions. So we'll just take them from the top. So first one reads, single policy engine requires a separate infrastructure?
Single policy engine requires a separate infrastructure. No. So the single policy engine really is about writing rules once, right? Like if you're going to do this sort of policy check, right? You want to write a rule once and have it, check your IAC. You want to have that same rule check your cloud. You want to have the results match each other as well, right? So again, the idea there being that, however you define a secure S3 bucket as an example, right? You should be able to define that once, and you should be able to check your infrastructure as code early. You should be able to check your cloud as well. And those two things should match. It should get the same result, as opposed to defining it in two different places, right? A lot of times what we find is there's a cloud security tool that's running. It has its idea of policies and how those policies are defined. There may be another tool that's checking infrastructure as code. It has its idea of policies and how those policies are defined. So the way that you could solve that is to write that S3 policy twice. Write it for infrastructure as code and write it for your cloud. But anytime that policy changes even a little bit, you have to go and update it twice, right? So you have to do a lot of work to kind of keep those policies in sync over time. And of course, you're going to have more than one policy. You're going to have several different policies, probably just for S3. And then you have all the different AWS resources and services that are out there. And then you might have Google and you might have Azure and you might have on and on and on, right? So maintaining two sets of policies is painful over time. And so having that single policy engine is better. The infrastructure for it, really shouldn't matter. It should be one.
Awesome. And so Jim, are you seeing those two questions just underneath that top one?
Yep. I see one. So why do we expect to drift and remediate later by running Snyk or some other different? Can we use GitOps approach for keeping automated, at least for IAC? So I think that refers to the idea that, look, you could if you have everything defined in IAC, you could just continually sort of apply or reapply your IAC. And it should automatically fix anything that's drifted in the cloud, right? You're sort of saying our IAC is our source of truth. Anything that changes in the cloud, we can fix by reapplying IAC. And that is potentially true if everything is written in IAC, if everything is captured in IAC, but it's not always. And that's part of the problem. And I think what a lot of people have in their existing cloud is they have some things that have been migrated from maybe from another cloud or from their on-prem data center. Those may not have been captured in IAC yet. You have people who go through the consoles of various types or through the CLI tools and other things, right, that are deploying things that maybe don't get captured in IAC. You even have like the silliest example, but it happens all the time, right? Is look, I just need to, SSH into a server for a minute to make a change. And then so I just need to open a port. I'm gonna do it for a second. I'm gonna close it as soon as I'm done. And then they forget to close it. And so the port's still open, right? So these types of things have happened for years and years, and they still happen today. So you could, like some of those problems you could fix by reapplying your IAC continually, but sometimes you can't. And you can't because they're not captured in IAC. So if it's not in the IAC, it's not in the IAC state. It's hard to say, what is the difference and how do I make that appear in my IAC automatically? It can also be hard because if a malicious actor gets access to your environment, right? A lot of times what they're looking for really is access to the control plane. If they get access to the control plane, then it becomes really hard to track that down, because what they'll do a lot of times is wipe out the logs and the things that you might go and check to see if something new has been created. And so the only way to sort of get that is to go straight to the source and be able to see that. So lots of things that can't be picked up just by reapplying all the time. And so it's good to have a tool that can kind of help, provide some of that. Now, that doesn't mean the GitOps goes away. I think the two things go hand in hand, right? So if you can identify all of these sort of missing pieces and then capture them back in code, then you can continually reapply the code. You should be doing that, right? I think that's still a best practice that you should be handling. And everything should be going through Git anyway. You want to have it there. You want to have it continually checked. You want to have the pipeline continually checked as well, so that you can manage all these things and implement changes as quick as possible, and so that everything is documented, right? Like you want to have it there so you identify any problems, whether they're security problems or they're just conflicts in how you deploy things, and things might break if you change a certain setting, right? You want to have it done that way. So I think they go hand in hand, but I don't think one necessarily replaces the other. So great question. Does Snyk provide SBOMs? SBOM details allow to track the differences of software versions between the two releases of the application. So yeah, answer to that again is yes. So the way Snyk works is that in order for us to find the vulnerabilities, this is specifically with two of our products that are specifically focused on vulnerabilities, Snyk Container and Snyk Open Source. We're building a full dependency tree. So we scan an object. We can scan an open source manifest or scan a container. We go and we build a list of packages that are installed and the dependencies of those packages and on and on. So we build a dependency tree. And from there, then we match that up with the vulnerabilities, known vulnerabilities, to identify the vulnerabilities are there. So we do build an SBOM for that particular use case. So the answer to that is yes. I will say, just by way of sort of full disclosure. That SBOM is in a Sneak format today, so it's in a JSON format. We have a tool, sort of an experimental utility that will produce that into a SPDX format. We are working on full Cyclone and SPDX compatibility across the board for those tools as well. But anyway, the short answer is yes. You can produce that vulnerability or the dependency list, the full dependency list, and you could check it later for differences, all those kinds of things. I think that's all the questions I see.
Yep, that's all I'm seeing as well. So how about I give away a couple of gift cards, and then we check again for any last minute questions that come in.
Sounds great.
So these are for 4 $25 Amazon gift cards. Our first winner is Kareem T. Our second winner is Emmanuel F. Our third winner is Warren S. And our fourth and final winner is Samina C. So to the four of you, congratulations. Keep an eye on your inbox to claim that gift card. But if you don't find that email, please check your spam folder. I'll also take this opportunity to remind everyone that this session was recorded. So say you joined us late, or maybe unfortunately you had to leave us early. The on-demand recording will be made available shortly after we conclude our live session. You can also find it living on the Security Boulevard website. Just visit securityboulevard.com/webinars and be sure to look in the on-demand section. So Jim, I'm not seeing any more questions. So Anything before we close out?
Nope, that's it. I appreciate everybody joining us. There is a handout there if you before we close down, if you want to grab that as well. White paper we have on the security from code to cloud and back to code. Be more resources that come up in a follow-up email. But again, thanks everybody. Thanks Techstrong and Security Boulevard for orchestrating everything today as well. Appreciate it.
Sure thing. Thank you, Jim, and thank you to Sneak for sponsoring today's webinar. I would also like to thank our audience. Thank you so much for being here with us. Please, we ask for one extra moment of your time for a brief post-webinar survey that should pop up on your screen. But otherwise, we do hope to see you at an upcoming Techstrong Learning webinar or workshop. Everyone, have a great rest of your day.